In this lesson, we will apply the fundamental theorem of algebra. And that essentially tells us that if we have a single variable polynomial, which is the only thing we'll deal with in this class, that has complex coefficients, that it will have at least one complex root. And we also know that if we have a root of a plus bi, then we also have its conjugate of a root. So here's how that's going to work. In this question, it tells us that 1 minus 5i, which is a complex number, is a zero of our function. So I'm going to use, and this is going to get a little bit hairy for a little bit, but I'm going to use that in synthetic division with my coefficients of 1, -3, 28, and -26. Now this is going to get a little bit ugly because of course I'm going to bring down my 1, but when I multiply, I'm multiplying by both terms, which gives me 1 minus 5i. Now the real part can combine with the real part of -3, so -3 plus 1 is -2. But here's the ugly part. I have to take 1 minus 5i multiplied by -2 minus 5i, which means I have to FOIL. So feel free to use a lot of scratch paper here. 1 times -2 is -2. That would give me minus 5i. That would give me plus 10i. And that would give me plus 25i squared. Well, I squared is -1, so 25 times -1 is actually -25. So this solution is -27 plus 5i. So that's what I have left. I had my minus 25 and my -2. So that's -27 plus 5i. I'm going to add that to the 28, which gives me 1 plus 5i. Again, I should be multiplying 1 minus 5i times 1 plus 5i. And when I do that, I get 1 times 1, which is 1. I get a plus 5i, I get a minus 5i, those will cancel. And then I get a minus 25i squared. We already talked about I squared being -1, so this is 1 minus basically -25, so 1 plus 25, which is 26. If I add 26 to -26, I get 0, which is a relief because they already told me this should be a 0, which means I should get a remainder of 0. Now, what I also know is since 1 minus 5i was a 0, 1 plus 5i is also going to be a 0 or a root of my function. So I'm going to put 1 plus 5i and do the same thing, and I'm just going to use those same coefficients I just ended up with on my last question and go from there. And I should get a remainder of 0, I'm hoping. So bring down the 1, multiply 1 times that, that's 1 plus 5i. These two give me -1, these two cancel. -1 times that would be -1 minus 5i, and I do in fact end up with a remainder of 0. What do I have left? Well, originally this was to the third, so this was to the second, so this is x to the first. So this is x minus 1. So my factored form would be x minus 1 minus 5i, which you could simplify a little bit more, but it's still pretty ugly, and x minus 1 plus 5i, and x minus 1. That's factored form. My zeros would be 1 minus 5i, 1 plus 5i, and then when I set x minus 1 equal to 0, I get positive 1. So those are my zeros. Let's try another. We are given that -1/2 is a 0 of this very long polynomial function, which means that's what's going to come in right over here, -1/2. I'm going to use my coefficients of 2, 1, 17, -9, -9. And I'm going to hope that I end up with a 0 in this box. Otherwise I multiplied wrong. Bring down the 2, multiply to get -1, add to get 0. Multiply, add, oh, I did something wrong already. Hold on. -1, oh, this is a -1. That's what I did wrong. So this is actually a -2. -1/2 times -2 is +1, which actually makes this 18. Sorry about that. Half of -18 is 9. So it's actually -9. That gives me -18. And then -1/2 times -18 is +9, and that adds to give me 0. Which means I could write what's left over. Actually, I will write what's left over, which is 2x cubed minus 2x squared plus 18x minus 18 equals 0. From here, I might have to use my PQ thing, so I would take numbers that, multiplied to 18 and numbers that multiplied to 2, but I see that I only have 4 terms here, and it looks like they're going to factor by grouping, which makes me very happy because it's going to be way easier. So factoring by grouping would give me 2x squared and then x minus 1, and would give me 18 and then x minus 1, which means I have 2x squared plus 18, x minus 1. And I'm probably going to go ahead and pop that 2 out, which gives me x squared plus 9 and then x minus 1. So my factored form would be x minus -1/2, or x plus 1/2. And then all of that, so a 2 and an x squared plus 9 and an x minus 1, and y, and that's all equal to f of x, of course. And why did I not factor this one anymore? Because it's not a difference of squares, it's a sum of squares. Now some people might write this instead, because I've got this 1/2 here. They might write this as 2x plus 1 by distributing the 2, x squared plus 9, x minus 1. And again, that's all equal to f of x. So that's factored form. My zeros, which is what I get when I set each of these equal to 0. One of them is, of course, that -1/2. If I set, that's what I get when I set this one equal to 0. If I set this equal to 0, I get 1. And when I set this equal to 0, again, you can show that work if you need to, I'm going to end up with plus or minus 3i. So that's -3i, positive 3i. Those are my zeros. Notice there are 4 of them. Here's one for you to try on your own. So try this question, then press play to check your work. So again, they already give me one of my answers. 1 plus 5i is a factor. I'm going to write 1, -2, 28, -4, 52. And I'm going to hope that when I get done, there's a 0 in the box at the end. Bring down the 1, multiply it by 1. Add those together. And now I'm going to multiply. So again, feel free to show that work. One times -1, 1 times 5i, 5i times -1, 5i times 5i. These two cancel. This turns into -25, so that gives me -26. Add those together, I get 2. Take this times 2. That gives me 2 plus 10i. If I add those together, that's -2 plus 10i. That gives me -2 plus 10i minus 10i plus 50i squared. 50i squared, remember, that's times -1, so that's actually a -50. These two cancel, so that gives me -52. And that gives me 0. So yay, I did that one right, and that was one of my zeros. I also know then 1 minus 5i is going to be a factor, and I'm just going to use these same numbers that I just ended with, using synthetic division. Bring down my 1, multiply, That gives me 0, multiply, add, multiply, and get 2 minus 10i, and those of course cancel to 0. So those are two of my zeros. This leaves me with x, so this was x to the fourth, these were x to the third, this is x squared plus 2. I know that that's not going to factor anymore, so factored form would be x minus 1 plus 5i, x minus 1 minus 5i, and x squared plus 2. The zeros would be those two answers, 1 plus 5i, 1 minus 5i, and then of course what I get when I set this equal to 0, which will end up being negative I radical 2 and positive I radical 2, because again, if I had x squared plus 2 equals 0, I would subtract the 2, and I would take the square root, and that would be plus or minus I radical 2.